think there's too much of this here. Please, is my screen still showing? Can you all see the arrow presentation? Okay, okay, great. Yeah, so um okay, so as I'm going through the presentation, if you have any challenges or you have any questions, you can prompt me. I hope Kenneth is going to be with us to be doing the moderation for me, to be prompting me as to when questions come. So, once again, those of you don't really know me, my name is Richard Gama, and I'm going to be your instructor for today. I know that the other instructors uh, on Saturday you guys had the R class. That's the first one, and that is a high level one. I'm going to take you guys back to the basis. So I trust you are all ready as we go into this. Are we all ready now? Are we all ready? Okay, I can see some yeses. Okay. And please, if I should be off in some point, just prompt me, and then we would be able to go. So let me share this now. Uh, okay, we are ready, right? Are you ready? Okay, so let's go. So um, I'm honestly going to be a little biased here because of the program we are doing, which is mostly concentrated on the bioinformatics. So I hope you guys are going to bear with me because everything is going to most of the things you're going to be most of the examples I'm going to be giving are going to be centered around that. So let's look at the outline that we're going to go through. Um, okay. Please, I hope you've all not lost me. Are you guys there? Oh God. Net. I think my network is okay. Hello. Can anyone hear me? Uh, please, can you all hear me now? I think I got muted somewhere.
Yes.
Oh, okay. Yeah, sorry for the inconveniences. I don't know what happened though. Okay, let's go back. So I was here. I want to know, is the font size and everything okay? Is he clear enough? Is he showing? Is he clear or is it too small so that I know how to resize the
It's
font?
okay.
It's okay.
It's okay.
Yeah. And I want this class to be very interactive, so I'm going to share this notebook with you guys. So check the message box here. I have shared the link to this notebook in the message box. I hope you all can see it. Can you all see it? Have you ever used
Yes.
okay. Yeah, so that's the notebook I'm going to be using. Now, I'm going to be using Google Colab. One, because I know most of you. I don't know the background of most of you here, but I'm sure some of you might be familiar with Google Colab. And then last time Ken showed you guys how to use R Studio, how you can download R Studio. Sorry, the other instructor showed you guys how you guys can get the R Studio and then download it, and then how to use the Posse. Um, that is also just like Google Colab, but that one is mostly concentrated with R. Now, if you want to start new from R in Google Colab, you you have to change your runtime. So if you come to runtime here, and then you come to change runtime, you can select the runtime type here. So you can choose Python 3, you can choose Arrow, you can choose Julia. So if you are working in Arrow, you just choose the Arrow and then you go. So that's the only thing you need to change, because if you open a new Google Colab and then you just start typing, you are probably going to get some errors because it is presuming that you are using Python. So that is the first thing I want you guys to take note of before we move on. If this one is clear with us, can I hear some yeses so that we move on with our class?
Yes.
Yeah, bro. Thanks.
Okay, great, great, great. I hope everyone is familiar with Google Colab, because yeah, before I move on, I hope everyone is familiar with Google Colab, by the way. I should I, if you are not okay, if you don't really know much about Google Colab, you can let me know so that
Let me know so that sorry. Hello, Richard.
yeah,
Hello.
yeah, hello.
I doubt if everyone here, a significant number will know about Coca-Cola. But if you can do just a quick, if it's not part of your core objectives for today, maybe just do a quick brush up, right? Then we could have another class.
On that.
Oh, that's
Okay.
another class. Okay.
Okay. So if you are not familiar with Google Colab, I think if you just come to, if you have, as far as you have a Google account, just go to Google and then type Google Colab. From there, it will take you to the Google Colab page where you can just it's very, it's not really that complex. I think it's just from there, just search for, just go to Google and then type Google Colab, and then if you type Google Colab, it will just take you to the Google Colab page where you can create new notebooks from there. So that is the way to go. um yeah, but it's actually not part of our objectives today. That's why I'm not really going to show that. But I hope that makes sense. If anyone has any challenge about getting setting up a Google Colab, we have the group chat. You can just let us know, and then we'll probably do a class for that. Yeah. So let's go. So today we're going to just do some introduction to R, and then we look at some basic data R data types, or data types in R. We also look at some R data structures, and if time permits us, depending on how fast we are able to go, we would be able to talk about conditionals and then loops, functions in R, and then some bonus tips and tricks that we might I would be sharing with you guys. So that is our outline for today. I just hope we are able to cover as much as we're supposed to go with. So let's start with what is R in the first place. So um, I would know, I would like to understand most of you. I know that some of you are coming from biology aspects. Some of you are coming from um, software development and all of those things. But R is just a statistical computing language. It's a programming language. Oh, sorry about that. It's a programming language, and this is mostly used for statistics. And then we also use it for visualization. You can also use it to analyze data. And one important thing is that you can also use R for machine learning. You can also use R for yeah, developing machine learning models. So this is mostly what R can be used for. Or it is. I like I said, I shared this with you guys so you could just read this. But the basic thing about R is that it is mostly used by data scientists, by statisticians, and then researchers. Those of you are coming from the research background, you will see that if you most of the in your results section where you probably have to present some results, some charts, some data points, some visualizations. Most of the visualizations that you present are done using R. So that is what R is for. Now, in bioinformatics, it is mostly a go-to tool for analyzing genomic data, for visualizing biological trends, and then building predictive models. So, as this class goes on, as to how long it's going to take, probably we would get to this analyzing genomic data. So we might just get some genomic data and then start analyzing them. We also be doing some visualizations of some biological trends. So we would be using um, some packets or libraries like ggplot and the rest. I think the last instructor had made mention of that the last time. So one thing I want us to understand is that arrow is just like a sweet knife, a Swiss Army knife. I don't know how many of you know that, but it's a knife that has two edges. You can swing it this side and that side. Sorry, my camera is off, so you guys cannot see me moving my hand. And you can use it to cut any way, any side. Any side you turn, you can use it to cut whatever you want to cut it with. So that is what arrow is about. Um, I know I'm being biased to those who are coming from the Python background, but R is a very sexy language. Sorry for my 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 word, but it that is what it is. It is used to create like um outstanding or astonished. Is it outstanding? Sorry for my English. Outstanding visualizations. So that is what we can use R for. I don't know. Some in our group chat, some of you were saying that R you fell in love with R. Yeah. I hope maybe after this class you will fall in love with R much. So that is the first part. I want us to look at some of the use cases of R. I don't know how many of you have opened the notebook, but if you did, you would see this. So in the domain of bioinformatics, we can use it for DNA or RNA sequence analysis, or we can also use it to know gene expressions. um if yeah, so I think I'm going to leave here, but if you just go back to um the models that we are taking on the Stanford data oceans, you would see that they use Python in the introduction to genomic. They use Python to be able to present the volcano chart or plot. Yeah, plot. You can also do that in R, and it's very, in fact, it's going to even look more astonishing than that one in the Python. So that is it. Now we can also use it for statistics. We can use it for regression, for hypothesis testing, and then for ANOVA. All these are statistical tests that we can run. We can also use it to create data visualizations, create plots, create charts, create graphs, and then use it to for your research and all of those things. We can also use it to develop machine learning models, classification, clustering. This is very interesting aspect of R. People argue that machine learning we should use we should use Python for machine learning, but the truth is that you can also use R for machine learning. So I don't know how long this class is going to take, but if we should get there, we will talk about it. You can also use it for data manipulation, for cleaning data, for transforming your data, for summarizing your data. For instance, we most of the data sets that we're going to get are not just going to be like a data set that doesn't that comes with that is clean. So we need to be able to clean those data sets. We can use data manipulations. We can use R for that. We have some packages like deep R, deep IR, and the rest, which we can use to do that. So when we get to this part, we would also talk about that. Now, one, I don't know whether it's funny because maybe it's funny to me because I did this, is that I added some jokes at the end of most of the sections. I don't know if it is going to be funny to you guys, but as you read them, if you find them funny, you can just let me know in the group chat. But if you don't find them funny, no problem. Maybe that this is not your side. So here, we just want to throw some dust on the Python people. That's why did the gene stop coding in Python? Because yeah, it found its true expression in R. Yeah, so the gene can really express itself in R. So that's why it stopped coding in Python. I don't know how that sound. I don't know how funny that sound, but yeah, that's just by the way. Now we also want to know, why do we need to use R? So R is open source because it has a free community. I think the last presenter, the last class you guys had on Saturday, the um, the presenter was able to show you guys where you can get some helps from and all of those things. So it's an open source. It is meaning that you don't have to pay to be able to use R. You just have it, install it, and you can start coding in R. So it's open source. And because it's open source, there are so many people who are also contributing to it. So there are so many people who are contributing to the R program, and then they are making sure that they create new libraries, they make R to be stable for everyone to be able to use it for their specific purposes. Now it also has so many extensive libraries that will be using. So like we have the buy conductor that is mostly used for bioinformatics, and we have deep R, we have tidyverse, all of them are there that we can use. We have ggplot, we have all of these libraries are there that we can use to be able to perform a specific function, just like we have in Python, where we have like pandas, numpy, and the rest that we can use for a specific purpose. The same thing R has. It also has a strong community with active contributors. I think I talked about this under the open source. We it can also be integrated, so it works with other tools and then languages. So for instance, you can create a Python script that can be transferred, or that can be packaged in R, and then you can run that script in R, and then it will work well. So we can also create maybe something in C++, and then create a wrapper. Yeah, we mostly call them wrapper, a wrapper for it, and then it will be able to work in R. So that is the its integration. Now it also has advanced visualization tools. These advanced visualization tools like ggplots, we mostly use it to be able to carry out so many things. And yeah, let me get back to here and check whether all of you are following. Please, I hope all of you are following, by the way.
Yes.
Okay,
Yes, we are.
thank you. And if like I said, if you have any questions, just hit me up. Yeah. So this is the first aspect. There's a first aspect. Now let's talk about our basic data types. By the way, how many of you have been able to open the notebook and you are following through the notebook? Or some of you are on your phone? Hello? How many of you have been
Eh,
how many of you have been able to open the notebook? Or some of you are on your phones?
we are with
Please,
our
we've been able to open it.
You've been able to open it?
but
Yes.
Okay, okay, that's good. If you're on your phone, no problem. I don't know if you could just copy the link and then use it later, or maybe I'll probably share the link in the group chat. Yeah, in the group chat later. So so that you guys can just go through everything that we are going through. I hope that's okay with everyone.
Yeah.
Yeah, but as those of you who are able to open this, these just follow along. Okay, so let's go. I think up to this point, I hope no one is having any question, any confusions, or any doubts that needs to be cleared.
Yes, you can go ahead.
Okay, okay, that's cool. Okay, then that's cool. Great. So let's talk about our basic data types. So, what do we understand? What do we even mean by data types? So we can define data types as the kind of data that a variable can hold. So I want you guys to take this as like a placeholder. Okay. So if I ask all of you right now, I could see that we have somebody called Joyce. We have Pedro. We have Sadia. Sorry if I did pronounce your name well. Now, that is your name, but that name represents you. So if I take somebody like Joyce right now, then the word Joyce represents you as a person. So the word Joyce becomes the variable. So now you, the person that the name, the word Joyce is being used to refer to, are what we call the data type. So the name that is given to you is just a variable, because that variable can be, because I know you know that we have so many Joyces. I don't know if that makes sense. Like you have somebody called Joyce, another person called Joyce. But then you are also Joyce, but you are a data type. So I don't know if that makes sense. If this that makes sense though. So R is able to handle different data types, and then like I defined this. So in R we have these basic data types include this. Let me increase this so that you guys can see it well. We have numeric data types, and these numeric data types could be, this is called double, and then this is called integer. So numeric data types are, it could be a double, meaning that it will be a decimal number. So 3.14 pi, which is 3.14, and then recurring values, or a whole number. It could also be a negative value. It could also be a positive value. Okay, I think I got disconnected again. Please, yeah, yeah, yeah. Oh God. Um, am I am I audible? Okay. Please, sorry. I apologize for. I don't know what is actually happening. Yeah. Okay. Let's get back. Um, please, can I know where we got to? We were here, right? Understanding data types, right? Hello, guys. Please, are we all following? Oh God, what's happening? What's happening? What's happening? What's happening?
Yeah.
Okay. Yeah. So please,
Hello, Richard. Can you hear me? We can hear you. I don't know if you can.
yeah. Can you hear me?
Yes, yes.
Okay. Okay. Yeah. I apologize. I don't know what is actually happening. Okay. So we got to this part. So our data types. Yeah. So I was talking about the numeric data types. So I said that we could have um, decimal points, which is called double. Um, we'll get to how we would be able to check the types of these when we get there. We also have positive or negative whole numbers that they are called numeric. Then we have the character data type, which is mostly used to hold numbers. Sorry, which is used to hold characters, so like letters, alphanumeric characters. So anything that contains alphabets and numbers, and then special characters. We use the character that it hosts the data type is character. Then we have the logicals. So the true or false, mostly we call them what, the boolean values. So in Python we call it boolean, so bool value. So true, false, those are these are the main data types in Python that we are going to go through. Now I have thrown some radio here. So I start with R. I help clean data and I make plots that shine. What am I? And then yeah, this is R programming. So this is just some little radio to keep you guys, yeah, um yeah, to keep you guys active. So let's move on to the next step, which is the variables part. So variables, like I said earlier, are used to store data values. So and then the syntax here is that a variable is usually assigned using this symbol. So a less than sign and then a dash sign, or you can use an equal to sign to assign a variable. But then, even though this is true, so let me show you guys something here like this. So we can say name equals to so my name is Gamma. So we can say name is equal to Gamma here, and then we could just say print name for us, and then it will do that. Well, where are we? Where are we? What is happening? Uh okay, I think I where is our runtime? Okay, so
So you made a mistake with the name, the spelling of the name. You made it
oh,
MAN.
okay, yeah. Sorry, thank you. And so name. Thank you so much. Thank you for catching that for me. Yeah, but that's very good. I don't know who spoke, but thank you so much for that. So the name is here is common. You can say that I've used the equal to sign to assign it. It's going to work. If you'd also use instead of the equal to sign, and you also use this, this, and then you also run this, it's also going to work. So we can use this. The reason why actually the equal to sign was introduced later into R, just so to make it easy, because some people were finding difficult in typing these two things, just to be able to assign a variable. But then R, to make it more R, in Python we call it Pythonic. I don't know how do we call it R. Is it ironic? Okay, that's just by the way. So this is what you can do to be able to assign a variable. So either you use sorry, either you do this, you can use the equal to sign, or you can use this. So let's say name one is gamma, and then name two is this. So if we should now change this to name one, you will see that it is still going to run, because it is still the same assignment. So the syntax in assigning a variable is you using this or using this. Like I said, both of them works perfectly well, but like this is mostly preferred. Please, is this okay before you move on to the numbers? Is this okay with everyone? Okay, that's good. Yeah. So okay, then let's move on to the next thing. Now the next thing we're going to be looking at is numbers. So what are numbers? Numbers are whole numbers or floating point numbers. So here I'm using weight as this is a floating point number, and then this is a decimal number. So sorry, this is a decimal number, sorry, floating point number, and this is a whole number. So when we assign these variables to these uh, data types. So if we come here, even though I'm going to show you guys how you'd be able to know the type of the data type of any given variable, if we come here and then we do type of, don't worry much about the type of now. When we get there, I would explain more about that for you guys. So if you should check type of, one thing I want you guys to understand when it comes to our data types is that by default, R gives a double to all numbers. Any numeric value that you give any, so far as a number, whether it's a floating point number or whatsoever it is, the type of it is a double. But then if you want to find the actual value or the actual class, there's a difference between the class of a data type and then the type of the data type in R. Because in R we have every numeric value is either of the type double or the type integer. So I would show you guys the differences when, okay, let me even do that here. So if we have let me give you guys the class. Let's find the class of weight here, and then you will see that the class of weight is numeric. So that is the data type that we talked about here. So the weight that we talked about belongs to the class of numeric, but then the type of data that it is the double that we have here. These are some things that we need to take note of, because in R you need to be able to know what you want to tell R to do for you to be able to get the best of it, like in any programming language. So the type of data, the type of function is used to tell us what type of value or what type of number the numeric value is the data having. But then the class is used to tell us what type of class or the actual data type that the variable is. If we do, let's even put age here, and then you see that it will still give us the same thing. So it is still numeric. If you should also put age here, you see that it is also still going to give us double. So this is what I want you guys to understand. Now, if you want to force a data type to have an integer, like I told you guys from the beginning here, that this is a positive or negative integer, then there is one trick that you can use to show or to make it an integer data type. So that trick is just to add the letter L to it. So for instance, let's say new age. So new age, and then we assign that new age to, let's say, 20. Now if we ask R to give us the type of new age, it is going to tell us that it is a double. It is going to tell us this is a double. But then if you add capital L to this and then you check, it is now going to tell us that this is what integer. So sometimes you would be doing some analysis, or you be doing some data manipulations, and then you want the data, you want your value, you check, and then the values are in they are double. That is the data type. But then they are all whole numbers. They are all whole numbers. And then you are wondering why, what is actually happening. The reason why it is probably they are all whole numbers, but then you are seeing them as double. The reason why it is happening is because R interprets all numeric values. The default data type that R assigns to all numeric values is double. So if you want to force maybe a whole number to become an integer, then you just have to add this L to it. Yeah, or sometimes you might be doing some analysis, and then you will see 20L there, and then you start asking yourself, is it like a unit? The 20L, is it a unit, or is he, what is he doing there? Maybe it was just something that they were using to be able to force R to be able to understand that the values that are there are all whole numbers. But please take note that if you should put a decimal point here, if you should do 20.0, and even if you put the L there, it would still, R will know that it is a double. So always know that anytime you put a decimal point there, even if it is 0 points, this, yeah, it is, yeah, it's going to give you, what was I saying? It's going to give you a double if you have a whole number, sorry, a number following it. But if you make it 20.0, it is going to show it as what? Integer. So 20.0, 30.0, 15.0, it will come as an integer. The type of it will be an integer. But if you start adding point one, point, let's say 1, 2, 3, and then you go, it is going to tell that this is what? A double. So take note of when to use the L and when not to use the L. So this is some tricks that you need to be aware of when it comes to you knowing the data types in R. So is this clear with each and every one of us before I move on to the next thing?
Yeah, it's clear.
Okay, great, great. Now, I will go to where we'll start talking about how we can manipulate data types and all of those things. But for now, I want us to just get the very understanding of it before we start diving deeper into other things. So the next one is characters. So characters are used to hold names. Like I told you guys from the beginning, it can hold an alpha numeric characters or alphanumeric letters. So we have A, B, C, D, the name of a person, the location where the person is coming from, or maybe a name of a drug, or maybe a name of a facility, or maybe a name of a gene, just like we have them here, um, where the gene could be a letter and then a number that is added to it, or yeah, it could be anything, a hashtag and all of those things. So that is what characters are. So characters are used to hold name of alphanumeric values. So here I've given an example here. So we have like a gene name. Like I said from the beginning, the reason why I'm using most of these things is because of the program focus that we are having. I hope I'm not being biased to some of you. So that is it. So we have a gene name, and then we give it this variable. So the variable name is this. If you guys were following Roy's class, you would be able to understand that he was saying that, oh, okay, so hey, computer, I want you to create a variable called gname, and then in that gname, put this value there. So what is going to happen is that the system is not knowing that anytime you want to refer to this, it means that this is what you are calling. So if I go to the class right now, I know that there is Joyce in the class, right? So if there is no Joyce in this, if there's just one Joyce in this class, if I she just mention Joyce, she knows that she's the one I'm talking about. So the variable here is referring to this. So anywhere at all that you call this, so for instance, if I call gname, so if I say print and then I'm printing gene name, I don't have to type the BRCA1 because the computer now knows that gene name represents that. So if I should print this out, okay, sorry, I didn't run this. So let's run this and then let's run this. So if I should type this is what it's giving me because it knows that this is this. So Joyce is this. Now the person who is called Joyce is this. Sorry, I'm using Joyce's name because she's her name that seems so short for me when I saw the list there. So I hope you guys will bear with me. So that is what variables are. And then, like I said, characters are used to hold this. Now, one thing I want you guys to understand is that we use anytime you want to create a character, you use a double um, column, a double quotation mark. You can also use a single quotation mark. So let's say we are doing a gene, let's say gene type. So gene type is let's just say K42I. Now, if we print the gene type, what will happen is that it's still going to give us the same thing. So you can use a single quote for it. In Python, we call this string, but in R, we call it characters. So you can use a single quote and then that is going to work. You can also use a double quote and that is also going to work. So that is it. But then you need to be consistent. If you are going to be using single quotes, use single quotes. If you're going to be using double quotes, make sure that you use double quotes. And mostly we also use the double quotes when probably you are naming something that has like an apostrophe in it. So like for instance Parkinson's disease. So when you want to type Parkinson's disease, you use the double quote so that it will be able to cover the apostrophe s that is at the front. So this is how we can create a character variable. And yeah, so this is for characters. Then the next one is called logical or boolean. So in Python they are called boolean. In R they are called logicals. So logicals is true or false. True or false. I want you guys to understand that okay, let's just say it's late. So let me show you guys something here quickly before we go. Now it's late. We can use T to represent true, Um, okay, and then is early. Okay, is F false. So now, if I should say print um, is late, and then we print is early, is early. Okay. Here you can see that we are having true and then what false. So in R we can use T to represent true. We can use F to represent what false. But then please take note of the casing. It should be capital letters because in R when you do okay, let me just use this. So it's late and then I use true. This is not recognized in R. So R does not recognize this. This is recognized in Python. This is how we represent true in Python. But then in R, it should all be in capital letters. You can also use this in R. So take note of this. So in R, if you want to represent logics or logicals or boolean as in Python, you use capital letters or just type capital T for true and then capital F for false. So is what we that is what we can talk about here. Yeah. So it's very important for you guys to understand this. Like I said, you type in small t and then capital T and then the rest are small letters is not going to work because R is case sensitive. So T represent true and then F represent what false here. So that is about that. Now, in R, there are several functions that we can use to be able to check the type or the class of a variable. I think I've illustrated this earlier, but let me use this part to be able to show you guys that. So here we can have numeric. Oh, sorry. We would be able to know a character whether it's a numeric character a variable whether it's a numeric variable or it's a character variable, a logical or a data frame, which we'll talk about. So here, if we have x, then we represent it, we assign 10 to x. If we check the class of x, the value, the variable x, it is going to tell us that it is what? Numeric. Or we can check the type of, so I think I illustrated this to you guys earlier where we check the type of and then the class of. So the type of x is a double and then the class of x is numeric. Like I said, class is mostly tells us the high level class of the object. So in R there are three high level classes of data types. So numeric, character, and what? Logic. Data frame is also we would, when we get there, we'll talk more about data frame when we get there. But I want you guys to understand these first three. These first three, they are the most important ones that we'll be considering here for now. Then we have the type of, which I think I've illustrated it here, but let me also show you guys here. So we have a gene A, and they want to know the type of gene A. If you do this, it's also going to tell you what the character, that is, this is what this is, a character value. Type of tells us the internal storage type. I think I already mentioned this earlier. This gives us the internal storage type, like how is this system storing the variable x. So it is storing the variable as what? A character. But then class is more high level. So if we go back to this side, yeah, if you go back here, I told you guys that numeric variables could be double, or they could be what? An integer, a whole number integer. So numeric characters, I wish that I could draw this, but if you take a numeric character, we have double and then we have integer. So the numeric is the high level, whilst the double and then the integer are the what the machine sees. So what the how the machine now stores that variable. So that is what this means. So I want you guys to now think of a class as what the object is used for, but then type of is how R stores that variable internally. So what can the object be used for? The object can be used, so this here can be used as a number. It can be used for as a number, but then the class is what the type of is what the machine stores it internally. So that is um, that is the high level. Um, uh, that is what I want to say. Sorry for the distraction. I hope I've not lost you guys and I'm still on. Please, can you guys hear me? Can you guys hear me? I hope I'm still available. Hey everyone, can you all hear me? Sorry, I was getting some calls intense, so oh boy. Hello. Sorry. Okay. Yeah, please, can you all hear me? Am I audible to you or uh, can Bina? What's happening? Hello. Hello, guys. Please let me know if you all can hear me because I don't know if. I think we are available now. Oh boy. Reconnect. Yeah, are we set? Are we set now? Um, can you guys hear me? Okay. Sorry for that. I don't know.
Yes, we can. It's good to have you back.
Okay, yeah. Thank you. So yeah. Let me just continue sharing this and then we move on. Okay, I think yeah we're here. So I was talking about this that you should think of a class as what the object is used for, and then um, the type of as how R stores it internally. Please, is this okay with us? Are we all following, by the way?
Yeah, bro.
Am I am I audible, guys?
Yes. Yeah, you are.
Okay. Yeah, sorry.
Thanks.
I don't know whether I was the one that was losing you guys or you guys were losing me. Sorry for that. Okay, so let's just continue from here. Um, so the next thing is mode. Now I brought the mode here because this mostly shows the mode of the object. Like is mostly like um, but previously, honestly, previously, they instead of using type of and then yeah, the type of, they were using mode, like in what mode is the data type in. So this mostly used for backward compatibility. So that is mostly, I don't really know. We mostly don't use this, but it's okay if you guys should know about it. So that is why I brought it here. Then we can also use what we call the is, but then some whether it's numeric or whatsoever it is function. So we can also check the type of variable directly using these, what we call the is numeric. So is this variable numeric? Then you check it. Is it a character or is it logical? So if we have um, one thing I want you guys to understand is that this here, you're asking a question. So if you ask the question, it's going to give you a logical answer. So whether it's true or false. So if we have x to be 42, and then we want to know, is this a numeric variable? So yes, if it is true, so here you can see that it is telling us that it is true. Is it a character variable? So if I should put a quotation mark here, and then we should check this, you can see that this is telling us that yes, it is true that x, which is this is a numeric, a character variable. If I should just clean this and put t here, and then we should check, this is telling us that it is true because, like we said from the beginning, we can use t to represent a true logical. So you can use this to be able to check the the data type of the type of variable of, the data type that a variable is holding. This is very, very important because we'll be getting into data sets where you'll be loading a data set, and you want to know what the columns are, whether the columns are integers, the columns um, are numeric characters, or they are logical characters. And then you would want to use this to be able to confirm. So is this, so is numeric, so is this column numeric? Then you just it will confirm if it is numeric. If is it a character, you don't need to confirm, because sometimes you want your columns to be having the same data types. You want your columns to be having the same data type before you can do analysis with it, or you can even do visualizations with it, or before you can even manipulate them, like you grouping your data. You can't probably mostly group like a numeric data type. So this is something that you need to know. So we use the is numeric or is character or is logical variables to be able functions to be able to confirm whether a variable is what type of data a particular variable is holding. So if you check and it is numeric and it is false, then you should know that, oh, okay, this variable is not a numeric character. So what is it? Then you can check the others to be able to confirm that. So that is what we do. So you can use this is numeric functions and all the rest to be able to confirm that. So here I just give some general examples here. So we have a gene. This is a character data type. Then we know that this is what a numeric data type. This is this is what a logical data type. So we want to be able to now confirm that using this. So if we use the class, so what class is a gene? It is telling us that it is a character here. The type of, we talk about what type of is, we talk about the difference between class and then type of earlier. And so what is the type of expression here? It is telling us that it is what, a double. And then what is the mode of status. The mode of status, like I said, mode was previously used. I don't know if it is still used though, but I might be wrong. um I might be wrong though if people still use it though. So that is, and okay, yeah, I think people still use it though. If you probably are working in a backward, maybe like an R version that is previous, a previous R version. So if you are using the previous R version, honestly, I've not checked the current R version though. But if you want to, if you are using maybe a previous R version, you can use the mode because it provides this kind of backward compatibility. So that is it. So you can also use the is character. So you want to know, is the gene here, is he a character variable, and then it is giving us what's true. So that, these are just some few examples that I want us to talk about. Then I have some video here. I don't know if that makes sense. Why don't variables ever get into argument with R? The reason why is that because they always type before they talk. They will always give you that type. You can't tell, you can't, R cannot go into any argument with any variable because it will always tell you its type before you work with it. I don't know if this makes any sense, or is it even funny at all? Is it funny? Guys, is this funny? Okay, no problem. I'm not going to answer you guys. So let's move on. Um, yeah, before we move on to the section 3, let me know if you guys are still following me. You have a question, you have any confusions that can be cleared. Hello, guys. Ooh, okay. I thought I was. Shit. Can you guys hear me? Oh, what's happening? What's happening? What's happening? What's happening? I thought. Can you hear me? Ken. Okay. Guys, I really apologize for this. I can't really tell. My network is really stable, but I don't know what is happening. Okay, yeah, sorry. Please, can we move on? I really apologize for everything that is happening. I Please, can we move on? Can you all hear me so that we move on?
Yes, I can hear you.
Okay. Oh God. Please, you guys should forgive me. Okay, I didn't know that. Please, can you all confirm where you lost me at?
On the radio.
Oh, okay, okay, yeah, here, right. Okay, so yeah, I think yeah, if you guys understand the radio, let's move on. I was asking, um, through everything that we just talked about, if you guys have any questions, any confusions, anything that you would want to ask or add or subtract, you can let me know so that we iron those things out before we move on. Any questions, any confusions? Oh, am I still there?
Yes, we are still here. We can hear you clearly.
Okay, so since you guys are not answering, I presume you guys have any questions, right?
Yes, go ahead, sir. Go ahead.
Okay, yeah. Okay, okay. So I'm presuming that there are no questions. So since there are no questions here, let's move on. Now there is one thing that let me also say this first. Let me put this across before we move on. That it is very very important that you take note of some of. I didn't really add this here, but there are some operations that we can do in R. Operations in R. I didn't put them here, but we have one. We can do A. Sorry. So one is addition, and in R we can let's say we have X, which is we are giving it 2.5, and then we have Y, which we are giving it, we are assigning it to, let's say, 3. Now we can add these variables together, so X plus Y, we can add these variables together. We can also subtract these variables using this sign, minus sign. We can also divide these variables using this sign. Okay, I think I'm putting everything together. So so this is for addition, and then we can also do, let me just run this. Oh, I think I cleaned that, sorry. So X plus Y is going to give us this. So we can add X to Y using this addition symbol. And then we can also subtract. So 2 is subtraction. Sorry if I didn't spell that one well. So let's say Y minus X, variable Y minus variable X. And then, so it means we talk about the variables already. So we are just taking X. We know the computer knows that X here represents 2.5, Y here represents 3. So we just having this, just like we having 3 minus 2.5. So 3 minus 2.5 is going to give us what? 0.5. We can also do division. So division. So in R, if we do y, this symbol x, that is division. Where are we? What? Okay, network. Okay, so I was talking about division here. Okay, yeah, so I was talking about division here. So this is 3. So we use this symbol for division in R. I think in Python too, you can also use this for it. And then when we get to modulo in Python, if let's say we have 8 dash dash let's say 3 in Python, this is going to work in Python. But in R, you can't use this. In R, we use the percent sign. So 2 of the percent sign gives us what? Modulo. So this is modulo. Um, modulo, is it modulus? How do you spell modulus? Is it modulus? Yeah, I think something like this. Sorry if I'm getting this wrong. I don't know. My spelling is wrong today. Yeah, so modulus has to do with like how many times would 3 go into 8. So it's 3 is going to go into 8. 8 that is what? 2 times remainder 1. So the number of times is going to go is the remainder is what we write. So 3 goes into 8, that is going to give us 6. 3 goes into 8, that would be like 3 times 2 is 6. Then what remains after that is what? Is 2. So if I should put, let's say I put 7 here, you will see that it's going to return 1 because 3 goes into 7, that is going to give us 3 goes into 7, that is 1. 2, so 2 times remainder 1. So modulus return the number remaining, so the remainder. This is very important because probably I don't really know if we'll be using it here, but when you get to data manipulations and the rest, probably you might want to know what how much values are remaining, or sometimes too in carrying out some experiments, you want to know the remainder. You don't want you don't want to know the number of times a variable will go into another variable or whatever it is. Yeah, I don't know if this is is making sense though, but modulus is this is how we represent modulus in R. Then we can also do exponentiation. So I don't know if this is 4 or 5. So exponent. How do you spell exponent? Exponentiation. Yeah, so exponent. So if I do 2 this, so this symbol 3, this symbol in arrow means raised to the power. So this means that 3 raised to the power 2. So this is what R sees this. So this is going to give us 9 because 3 times 3 will give us what? 9. So these are some basic operations that we can do in R. Now, apart from these, there are some other operations like they're not operations. So for instance, if I use this symbol and I say true, it's going to return false because this symbol represents not. Or I think in Python you can do not in Python. I don't know if that works. Or there is no not. Okay, yeah, there is not in Python. Yeah, here we don't have anything like not, so you can just use this symbol to represent not. And then we also have other symbols that we can use for operations like um, double what do we call this? Double pipe sign. The pipe symbol. What is my pipe symbol? Okay, yeah. So this pipe symbol means so let's say false this true. This is going to return true. So this symbol is used to represent or. So this is used to represent or. So if I also say or this, is it? Yeah, this or this, and then we have and we have or. So this is for or, and then if we want to confirm and, if we want to confirm for and, we use the end percent, sorry, the end symbol. So if I say false and true, this is going to give us what? False. Why? Because when it comes to end, sorry, I think I don't have a highlighter here to write some things in the logical tables. I don't know how many of you know this, but when it comes to logical tables, true and true is true. False and true is always going to give us false. True and false will also be false, and then false and false will always be false. But when it comes to or, any, so far as there is a true in it, it will become true. We would be using this as we move along, because we are in data manipulations. You want to be able to know whether some variables are more than this or that. So we'll be making use of these symbols. So this symbol is used to represent or, and then this symbol is used to represent and. So this is or, and this is end. So it is very important for us to understand these symbols as we move along, because when we get to matrices or vectors, or when we start manipulating data, we'll be creating, when you bring double or, there is something that I will talk about when we get there. That is when you are comparing two vectors. So when we get to the data structures, where we'll be talking about vectors and the rest, we would probably do this to be able to understand how to make use of them. I hope these operations are okay with everyone. Please, is everyone okay with these operations before I move on to the next thing? Yes, okay, so I think I'm audible enough. Thank you guys very much for your replies. But then, the way you guys are not asking me any questions, I hope I am not confusing all of you. I hope I'm not confusing you guys. Because if you are teaching and then your students are not asking questions, two things: either you are confusing them or you are convincing them. So which one? Yeah, so I want you guys to tell me which one. Am I confusing you guys or I'm convincing you guys?
No, you're very
Okay. Until now everything is good. Okay, that's well noted. Okay, good. Um, so let's move on to the next part. I hope we are able to complete this before our time goes out. Yeah, so we have some few things. If we are not able to go through the data types, maybe in our next class we would, the data structure, sorry, in our next class we will go through them. We'll go through them. um I would like us to end by 8, 8 o'clock here, which is in okay, so let's do it this way. I think I would want us to close on a dot here, like by, I don't know, some of you on a, here is going to be like 8 o'clock. I just to take the 30 minutes out. Sorry for that. So let's use this opportunity to ask some questions to clear your doubts and whatsoever it is, if that is okay with all of you. Or if you guys want us to fire out, we can. Or to fire on. I think we don't have any word like fire out. To fire on, you can let me know. But if you do have any confusions from what I've said from the very beginning, you can let me know so that we use these few minutes remaining to iron some things out before we move on. Before we close for the day. So I'm with you guys now. Questions. Questions will come when we start applying the operations. Okay. Okay, that's cool. That's interesting. Yes. So what do you guys say? Should I fire on, or we ask some questions to get some clarifications?
There's someone who raised a question in the chat section. If you maybe want to take that one out.
Okay, yeah. So how do you use Colab? How do you use Colab to run R? Okay, that's a great question. So if you could see my screen still, I said that when you open Colab fresh and you've not typed any code yet, if you have this notebook that I've sent to you guys, if you, as far as you just open it, it's going to run automatically on R for you. But you want to start from the very beginning with R. What do you do? Because if you start typing R codes in Colab, it's going to throw you some errors. So what do? You, before you start everything, come to this place. So you come to run time, and then you click on a runtime, and then you scroll down to change runtime type. So you click on this, and then this is where you change the runtime and the runtime type. Okay, there's so many T's in this. Okay, let's go. So there is Python theory, this is the default one. Then there is R, then there is Julia. I don't know how many of you know or work with Julia though. But yeah, that's it. So yes, select the R, and then you just click on the save, and it's going to take you there. So that is how you set up R in Google Colab. I hope that question is answered.
Okay,
Mora,
Richard,
in your,
just
yeah.
Yeah.
just a quick one. I was thinking maybe you could use the remaining minutes to just give a walkthrough of the Google Colab interface or something like that for those not familiar with it. Maybe
Oh, okay,
if
okay,
convenient.
okay. Then let me do that.
Okay, then let me do it.
So let me stop sharing
So
this
let me
one.
start sharing this one.
Then
Okay.
so let me
Let me
share my own screen windows. Okay, should I? Okay, let me share entire window. Yeah. I hope my screen can be seen. Can you guys see my screen? If you
Yes,
can
we can. Go ahead.
just, okay, great. So you come, you open a new, your Google search, then you just type Google Colab. So you just go to enter, and then you'd come to this place, so Google Colab. So when you open Google Colab, the first thing it's going to do is that if you have not created, if you don't have a Google account, it would it will ask you to log in into Google. This is taking long. happening? What is happening? What is happening? What is happening? What's happening? Maybe you could start. Whoa, 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 God. Shit. Jesus. Yeah, Ashat. I don't know. Yeah, Ashat. Sorry, I don't know if I pronounced your name well. I would come back to your question, okay? Like I see that your hand is up. I would answer it. Uh, yeah, I would come to your question, okay? Sorry, are you guys here? So you come to Google Colab. You search the Google Colab, and then you can when you come here, you just go to new notebook. So let me click on that.
Hi, please. We can no longer see your screen.
Yeah. Oh, sorry. I'm really sorry. I was. Hey, God. Sorry, you. Sorry, guys. I was talking. I thought I was presenting. Yeah, sorry about that. Can I hope you guys can see my screen now?
Yes, it is up now. Thank you.
Yeah, thank you.
Yeah.
Thank you for pointing that out for me. To me, sorry. So you search Google Colab here, like here, and then it will take you to this place. So you click on this. If you've not logged in, it will ask you to, if as far as you have a Google Gmail account, you can just log in from there. And then after you log in from there, you come to new notebook. Since you are new, you just come to the new notebook here. So you just click on this, and then it is going to open a blank notebook for you. So this is loading. Okay, so this is loading. So this is going to create, so this is going to create a new notebook in your Google Drive for you. So if you, okay, before I show you guys the Google Drive. So here, this is the fresh notebook that I've just opened. Like I told you guys, if you to start working with Python with Google Colab, after you open a fresh new notebook like this, you click on this connect. So you just click on the connect, and then it's going to allocate a new, you can see here it's connecting to Python 3. So by default, I told you guys that by default this is going to run in Python 3. So if you want to change the runtime, then you now come to runtime, and then you go to change runtime type, and then you click on this, and then you select the R. So when you select R here, then you click on save, then it will now change the runtime to now to R, so connecting to R. So this is what it's going to do for you. But then if you, by default, if you come to Google Colab, it's going to give you, it's going to leave, it's going to be in Python. So you do this to be able to change the runtime to that. Please, I hope this made sense, and this is what the question was about, by the way. Yeah, the one who asked the question. stop sharing this. Okay, yeah, you can't hear me. Please, can you guys hear me?
That was then, sir. That was then. We can hear you
Oh,
loud and clear now.
I hear
oh,
you very clear, sir. Very clear and loud.
thank you. Please, I hope how the demonstration I did for the Google Colab is
And
yeah. Ken, I think you were the one that's asked that. Is he okay now?
Yes, sir.
Is everyone
I have a
okay?
question, sir.
is everyone okay? Yes, I wanted to chip in something. Maybe just for those who may not know what Google Colab is all about, that's a cloud computing platform, sort of free for most basic uses, and it's offered by Google to anyone who has a Google account. Just like we demonstrated in the previous class about Anaconda, which gives you everything you need in an environment. So Google Colab is one of such. And it also offers you some advanced features such as powerful GPUs, which ordinarily your local device might. Sorry for the background noise, which your local device might not have.
Okay. Um, I think Ken, are you there or we lost you? Okay. Ashat, I don't know if I got your name clear, but I think I saw your hand earlier. Your hand was up earlier. I don't know if you could ask your question. Is Ashat here or
Yeah,
is
yeah, I am here. It's pronounced
okay?
Aisha.
Oh, Aisha. Oh,
Yeah,
sorry, sorry.
thank you so much. Thank you so much for the session. It's actually like very well explanatory, and I am able to follow through and through. I'll definitely get my hands on like some parties after the class. So my
That's
question
good.
is actually not really entirely about it's about
Okay.
Python. So I'm
Okay.
actually new to both coding languages. I mean, I've never learned a line of code before. So while making my research, so a friend is a developer mentioned that there are there is difference in in Python for
Okay.
web development. They
Yeah.
and there is like for data science and
Yeah.
for machine learning.
Yeah.
So I don't know if you can just give a brief of like the distinctions between them. And of course for me like this, the reason why I'm actually learning this is because I'm interested in computational neuroscience. So I think
Okay.
am I expected to like learn all round, or there is a specialization like maybe just Python for machine learning or just Python for data science that I'm supposed to learn? I think I don't really need Python for web development
Yeah.
apparently. Like, I need to like please just like make distinctions between the three and just advise me on which one I should focus on.
Okay. Okay. Great. Great. That's a nice question.
Thank
So
you.
I'm going to say it in my point of view. I hope Kenneth will be on soon to also add his view, and then all of you, I know all of you can also add your view. So this is my point of view. So um, last Sunday, I don't know if you were in a class when Kenneth was making his presentation. He talked about the difference that you were available.
No. I just joined the group few days
Oh,
ago. So I
okay,
wasn't.
that's the problem. So Python can be used for web development, just like you said, that is correct. Python can be used for game development. Python can be used for cybersecurity. You can also use Python to develop standalone applications, like it could be a desktop application or even a mobile application. And then we can also use Python for computational science. So we have actually we have what we call the scientific Python, and then we have the core Python. So the scientific Python is mostly what is used for data science, machine learning, and then data visualization and all of those things. So with what you are saying, I would advise, or I would say that they should go in the direction of the scientific Python. Don't really go into web development because you're not really going to need it in where your direction is in. So this is where you're going to be learning things like pandas. You'll be learning things like Python for statistics, Python for we have libraries that are in Python that are used for computational science. So I think the assignment that you'd have to take now is to go and search for like which libraries, yeah, because in Python, um, knowing Python is more about you knowing the libraries. If you are conversant with the libraries, you are good to go. So know the libraries that you're supposed to work with. Okay, I there was I can't remember that, but there's is it is something bio something. I've forgotten the library. It is mostly used for biostatistics, yeah, and bioinformatics and all of those things. Yeah, so there are so many libraries that are even used for implicating genes, like to be able to create genes and all of those things. So what I would say is that concentrate on the scientific Python, and then search for libraries that are mostly concerned with what you said you are interested in. So, for instance, if it is machine learning you are interested in, then probably you need to learn s scikit learn. I don't know why I'm pronouncing that thing like that. Yeah, scikit learn, and then maybe probably PyTorch. You go into that aspect and all of those things. Yeah, so that is what I can say about this. I don't know if um Tanaka and then Kenneth. Sorry, I don't know if I'm murdering people's name today. I'm sorry for that. And Ken, if you guys can say something about it. Yeah, I hope you got me or anybody.
Yes, I got that perfectly. Thank you so much for the clarification.
Okay,
I'll
yeah,
follow
yeah.
up. Thank you.
Yeah, yeah. So don't worry if anything you can we are in the group, you can just hit us up, and then I we can direct you to some resources you can follow. Yeah.
Yeah, thank you
Sorry,
so much. I'll do.
sorry for the interruption, sir. Sorry for interruption, sir.
No problem. Please just go ahead.
Yes, sir. What about me that I'm interested in health data science? What advice do you have for me, sir?
I think I would give you the same advice. So health data science to you the same thing. Like um honestly, please, I apologize because I there are people that there are some projects that I work on, but I've actually forgotten some of the things that we are. Oh God, can you guys hear me? Yeah, can you hear me?
Yes, sir. Yes, sir.
Yes.
Yes, sir.
Uh-huh. So I worked on some project with some guys, and then where we used there was a library. I'm sorry I can't remember the name of the library because it was I think last 2 years ago. That they used to you when you get a data set, you you can enter what's they call it smile. I don't know if those of you are in biology, you know it, a smile. It's just an acronym, but it's called smile. So you just enter, you give the smiles to that, you just provide the smiles um to that package, and the package will be able to generate some various features about those genes and those plenty things. So what I would advise is that concentrate on the libraries. Just go to your I think chat GPT and the rest, and then ask um, which Python libraries are used in a field that you are interested in going to. So if you use, I think if you do that, they are going to give you specific libraries. So concentrate on mastering those libraries, because if you are able to master those libraries, that is what is going to make you perfect. Yeah. So I think that is the advice I'll give you though. I know Ken's hand is up. Maybe he has something to say.
Okay.
Yeah. Please, I hope that makes sense, right?
Yes, thank you so much, sir. Thank you so much.
Okay. You're
All
welcome.
right. So,
Okay, Ken.
sorry, apologies. I couldn't stop while I was just getting back home, and that would have loved to chip in. So I hope you can hear me.
Yeah,
Hello.
yeah, yeah, yeah.
Yes, yes, yes.
Hello. Okay. Okay. So I wanted to chip in. So regarding the first I chat also that asked the question about whether if I got her right, whether she should just learn Python or if she's interested in a specific field. Maybe I'm not so sure, I was distracted. So my advice on that would be that number one, um, learning Python is like a learning a language, just like they call it language. It's a programming language, but it could also use your knowledge of a normal human language. And if you want to be a medical doctor to practice in a country like Nigeria or in the United States or so, the first one of the first things you need to know is how to speak the language of the people, right? So the moment you learn the language, right, you have crossed a significant barrier, right? In the sense that with that language, you can now start applying it into any other field. And the good thing about programming languages like Python and rest is that, so I'm using Python, even though this is our class, but it applies in general to almost all programming languages. Like if you want to learn the syntax and you can define functions, you can do all that, right? Within that using a particular language, right? Then then you can apply it to almost all sectors or industries that you want to delve into, right? Okay, say with website development for those who know about the framework in Python for learning web development. But now I'm into data analysis, and then the same knowledge of Python still followed me through, right? So the moment you learn the syntax, right, then the next thing you're going to look at is how to specialize, like getting to master a framework that is for the particular field you want. So, like Richard was trying to mention, yes, I worked on a number of projects. For example, in a particular case, I worked on a cancer, like a that is trying to is predicting the carcinogenicity of chemical compounds using their SMILE strengths, right? I think that's what he was trying to point out. Kind of. Now there are frameworks. Frameworks are like the analogy I used in the last class on Sunday is like if you are making a cake, right? Instead of going to different stores to buy different condiments, items you need for that cake, right? Framework is like a full package that contains almost everything you would need to make a cake, right? So the same result applies in framework and in programming. So if you are focusing in the field of health sciences, right, there are frameworks for that. There are libraries, codes that have already done the heavy lifting for you, so that what you now need to know now is to know the different APIs or the different functions or sub libraries within that framework and to master how to call them and apply them to what you want to do. So just to put everything together, the first thing is to know the syntax. Then the other one is now the domain knowledge that is bringing it into context in the field you want to practice. In. So adds additional clarity to what Richard has said earlier on. And
Yeah, thank you so much, Ken. Thank you so much for your input. I found it very valuable.
welcome.
Yeah, I'll continue learning as you said, and of course, if there's any question I would like to ask, I'll definitely reach out to you guys. Thank you so much once again for the class and
Then there's this trap you should try to avoid actually. Like it could be tempting to just learn for the sake of it. And what I'm telling you now is based on personal mistakes, right? So when I started learning, right, I just started learning for the sake of it. I didn't have any structured curriculum I was learning from. I didn't have any instructor, that kind of guidance or mentorship. I was just learning on my own. So today I could go on YouTube and and all that. But it didn't give me a specific focus. So what I strongly recommend is that even if you want to apply your programming skills, like even if you want to learn programming, try and start from the early stage to apply it into somewhere. It could be that you want to become like you have to define your purpose before you start learning in the first place. What do you want to apply this thing into? Is it data science? Is it web development? Is it desktop software application development? What exactly is it gaming? Now you start from the early stage to start learning to code using those frameworks or those frameworks that will be relevant to the field of application that you want to delve into, right? So it will give you a sense of purpose and it should help you to check your progress over time and you see that you are running with direction. It's not just about speed, you need to also have a good direction, right? So it's one trap that learners are usually prone to. And one way to avoid it again is to learn using a structured curriculum. Those that will teach you a number of the basic things that you may not even know about, we have that is like that we even had people who stay in India and all that, and this is actually midnight over there. So we'll look at it and then we'll address that. But just endeavor to join the next class and then please remind me of that again. Let's look into that.
All right, thank you so much, sir. Thank you, sir.
All right. Well, Richard, if you still have
Yeah.
anything to say, although they've been dismissed indirectly since you, but if you don't have anything
Oh,
to chip in, you could just.
yeah. I think you've hammered it all. So yeah, that is it. Thank you guys so much for coming. Please, if there is no questions, if there is nothing else to add or to subtract, then thank you guys very much for coming and for your time. And I hope we deliver to your expectation. And then we look forward to see you guys in uh, class next time. Yeah. And I think bye bye for now.
All right. Good night, everyone. Bye, everyone.